it's Friday already. Welcome on the stream. Today we're gonna talk about Nix and reproducibility, but I'm gonna wait 5 minutes for people to join the stream. So if you watch this on YouTube, just skip forward 5 minutes. All right. Hey. Hello, Pnidvitsninski. So I guess while we're waiting, we could talk about a little bit what happened this week in the Nix community. There's a pull request that Elko Hope opened that's going to add Nix configuration to the flakes. I'm quite excited about that. This will allow you to have per project substitutors and other configs. So that's going to be quite useful. What else? So I'm actually Jonas Chevalier. I don't think I mentioned that before. I decided to become public with my name. It was too much work to maintain two identities. And I'm a Nixos and DevOps consultant. So I actually help customers be productive, and I do that through build and software infrastructure that I put in place. So if you want reproducible builds, if you want productive developer environments, if you have special requirements, I'm here to help. Let me see. I also acquired a new microphone, so I might have to tweak that. Is it better when I'm approaching the microphone? I can try it like this. Now I'm holding the microphone, it's not ideal. Alright. So if you follow me on Twitter, Zimbatiem as well on Twitter. I've been posting for the past 2 weeks that I had like a weekend project and I wanted to make Nix more reproducible. So this is basically the things that I've learned. I've approached the reproducibility world before. I went to the Reproducible Build conference in Paris 2 or 3 years ago. So it's not a subject that I'm completely unfamiliar with, but it was a good refresher and it's interesting. So I thought I would share today what I learned and maybe a few concepts. So stay tuned. So what is reproducibility? What does it mean? I think there's some confusion. So there's really two definitions that people have in their head. And so this presentation is actually, by the way, first a small overview of what is reproducibility and what does it mean. And then I'm going to dive into the Nix specifics and how we implement this. So two definitions. Some people, when you say reproducible, they really think repeatability. What they mean is I have a Docker file and then another developer runs Docker build and it builds for them as well. So repeatability is just a weaker form of reproducibility where you can run the build again and you get an artifact again. And often the repeatability is premised on having access to the third-party dependencies that you're going to load from. And it's actually a big subject on its own. For example, Lewo in the Nix community has a project with the Software Heritage Foundation, and what they do is they back up all of the source files that they can find on the internet. And that helps with repeatability, because 5 years from now, if you rebuild a project, often the source has moved location or has completely disappeared. Who knows, like maybe GitHub in 5 years doesn't exist anymore. We will move to some other system. So it's an interesting property, but it's not a complete story. So the other definition of reproducibility is independently verifiable. What that means is you can, as before, run the build again, but there's an additional constraint which requires that the output of the build is exactly the same. So you can also say bit reproducible or deterministic builds. Deterministic builds is more like the mathematical view of the problem, where you treat the build as a function and the output is deterministic. And so that's this definition here. Reproducible builds are a set of software development practices that create an independently verifiable path from source to binary code. This is the project called reproduciblebuilds.org that has this definition. And they're really the first project that I know of that tried to tackle the reproducible builds. And this is coming from the Debian universe. They did a lot of great work building the foundation to make this work possible even for Nix. And we're going to see later, why Nix is not reproducible actually. Lots of people hear Nix is reproducible, but it's not entirely true. It makes it easier to be reproducible. So what's why do we do that? Why do we care about being reproducible? So one aspect is security, meaning if you can verify if you can have independent actors building the same thing, and then you can compare the outputs and just verify that it's the same, right? Hey, Contrin. Yeah, let's chat. I'm just doing the presentation and then we can chat. So, where was I? Yes, so the security aspect is important. I don't know of many projects that actually go that far, but you could imagine we have 2 Hydra farms going, right? And then we compare the outputs, and if both Hydra farms have the same, then we record that and we say, okay, this is secure. And hopefully, both Hydra are managed by a different set of people. And that's how you build trust. And then the second important benefit is the content adjustable storage, meaning if you can hash the output, then you can store it as a content adjustable object. And that feeds into one of the streams we did before on IPFS. So, yeah, Nix is about purity, and here there's this sort of ultimate goal of purity. So why are builds not reproducible? There are many causes of impurities that you can have in a build. Nix has the build sandbox, so it prevents a lot of these impurities, but it doesn't prevent all of them. So typically, if you fetch the sources and you don't get the same tarball, that's solved by Nix, but other build systems might not have this. Sometimes you have the file ordering, or like when you sort items in a list, UTF-8 has a collation rules that are depending on the local of your system. So that can be a problem, obviously, if you don't have a sandbox. And then any build that embeds the time in the output, typically when you build manuals, they like to put the time when it was generated. Dev random is also a source of impurity. And one that not many people know about, I think, is the file ordering issue. So actually on POSIX file systems, each file has a unique ID, and that's called an inode. And the inode is a number that just is, there's a list of inodes available, and the file system, when you create a file, just picks the next one. It's like an auto increment for the file system. And because the Unix readdir syscall, for example, returns the files in the inode ordering, you can actually have sometimes the list of files that change order based on which file system you're at. And then there's many more different sources of impurities, like you could imagine reading system information, embedding the host name. There could be a genetic algorithm, for example. I think there's some scientific libraries that actually try multiple algorithms, and then depending on the CPU, they pick the one that's the most performant. And so if you build on different hardware, you get different files. So how does it look for the Nixos project? So Graham built a website for this to track the reproducibility on the Nixos project, which is awesome. And what it does, I think it's a cron tab in the background that builds this website periodically. And it tries to build the ISO minimal. So it's just a subset of Nix packages. That's, if you can see it's 98.84% of this subset of Nix packages. But I think it's a good milestone, you know, like if we reach 100% for this, that would be awesome. And then once we reach that, then we can expand the scope to maybe the ISO graphical, so we include KDE and all of that. And here you can see all the unreproduced paras. And there's also some instructions on how to do it. How do you find out if a build is reproducible? And then how do you inspect the difference to figure out, you know, what's the problem? Where does it come from? So over the 2 weekends, I got some help from a few members of the community, and we fixed this. In this list, we fixed the Ruby packaging, the Python pip packaging, which actually I broke for some things, and then Fried went behind and fixed, so lots of thanks to him. There's also some duckbook generation that got fixed, and I think AutoGen, Wayland, and NSS. So we'll look into this a bit later and see the outputs. So yeah, that's it for the overview. I recommend this project. They do amazing stuff. And then check out r13y.com. That's where Graham's website is. And then if you want to participate, then join the Nixos R13y. There's a R missing in the slides. On Freenode. And we can coordinate our efforts there. Okay, so how do you know if a build is reproducible? So Nix has a --check command that you can run. And even if the output is in the store, it's going to rebuild it. And it's going to actually put it in a store path that is not really a store path that has a .check at the end. And you want to add the -- keep failed so it doesn't actually delete the output. So I think this should be implicit when you run --check, so that would be an improvement you could bring to Nix. So let's look. For example, if we see the... okay, I forgot to mention, there's this tool called Diffoscope, and that comes from the Reproducible Builds project. So they created this tool, and it's a sort of smart differ where it knows the structure of some binary files, and that improves the output that you get. So it's like a diff, but it also knows how to read binaries. And in the dbus package, what we see is you can see some IDs here are randomly generated, right? So that's an issue. And this is an issue we found out that in DocBook there's a flag that you can pass to make these reproducible. So fixing these issues often comes down to be good at debugging and figuring out where the source of impurity. First understanding the source of impurity and then being good at drilling down in the code, finding the right place where it's wrong, and then submitting a patch, hopefully upstream. So this one is just random stuff. Okay. So that's one of the impurities. By the way, these are fixed, but they're in the staging next branch right now. So it's gonna be 99 point something % once staging next is merged into master. The bootstrap pip is also an interesting one. Here what we have is that's the build system embeds the temporary folders into the output. So when the wheel gets built, it creates a temporary folder on the temp file. There's you can recognize the /build that's from the build sandbox. And then it creates this temporary folder, and part of the temporary folder is a random postfix. So that's annoying. This was a regression in pip, which was then I made a patch to make it not put the random here, but it had some regression because you could still have name clashes. And I then upstream fixed it properly. So now we're good. Python, I don't really understand this one yet. It seems like the debug output introduces these files. Hey Kelly Jack. So we're talking about reproducible builds, and you should check out the first part of the video. Autogen. Here, this build is completely reproducible, except 1 byte is different. So I don't really know what's the problem here, but I think it's got fixed. And in Ruby, we had some other source of impurities. So here again, we have a timestamp, which is not great. And then we had a random postfix. And then here we had the file ordering issue that I was mentioning in the presentation. So the files are sorted differently depending on which file system you're on, which means that, you know, in the Ruby code, you have to call sort after the list of files to make them predictable, basically. But it turned out this file is included in the output, but is only used to build the SO files that are part of the Ruby gem. So the solution here was just to delete the file, so that was easy. I still made a patch upstream to make it more reproducible, but we don't need the file anyway, so it's good like that. NSS here, this one was interesting. So it turns out that there's a standard called FIPS 140, which is a government mandated thing by the US. I don't really know the detail, I'm not a crypto guy, but what it needs is for each of the SO file, it generates this signature file. And so it generates a secret on each build of the package, and the secret key is sourced from a random, so you always get the different results. But we don't really use FIPS 140, so I submitted the patch to turn off this. Actually, the library was not built with the flag, but it still generated the. So there's a build flag to enable the FIPS 140 feature, but it was turned off by default. So I just removed these files again. So it seems like this is my solution. Oh, so LibreSSL also. Does it mean that LibreSSL doesn't support FIPS, or? Hey Softinho, welcome on the stream. I see. Well, I think if you need FIPS 140, I added the enable flag so you can rebuild it, right? The tricky part here is actually part of the spec is that the source should be random. If you know the signature keys, then it breaks the crypto. So it's like really hard to make it reproducible. We also have, this is GCC. So we have here just as a observation, most of the derivations are reproducible, except the important ones like GCC, the Linux kernel, you know, like the really core parts. So hopefully we can make those reproducible. So this one I don't really understand it. You can see there's some randomness, but I don't really know where it comes from. And then Guile is a scheme interpreter by the GNU project. And again, there's some source of randomness. Sometimes it's tricky to really understand where it comes from. Yeah, that's a good point, Kilijak. For what you could do is actually generate the files after the installation, maybe in the activation script instead. And so they would be host specific. Actually, might be actually even more secure, I don't know. Here it looks like the Linux kernel embeds a build ID. And then there's some, I think Andy looked into it, and there's some flags, so some build flags that add some randomness to the kernel as a protection measure. But again, that sort of goes against the reproducible builds. So yeah, there was rsync, that was also interesting actually. So in this one, if you go below, or no, that has changed, I think. What we had before is the so last week we've seen that you can generate data. So each C program has symbols that it exports, and when you link the projects together, the ordering of the symbols would change, and that was not reproducible. And we found a GCC flag that you can use to seed. The ordering is actually determined by a random generator, and you can pass a seed. So we use the output path as the seed, and that way it's both random and reproducible. So yeah, that's it. I don't know if you want to have more of a demo. You know, like I can show you how it works in practice, but it's really like you run the Nix build, then you run Nix build with --check and --keep failed, and then you run diffoscope on both star paths, and you see the difference. What does TerraGrant has to do with reproducible builds? Yeah, diffoscope is amazing. The other thing that the foundation, the Reproducible Build project has done. So if you dig in Nix packages, let me just bring that up. Okay. So what they did is they introduced a standard called source epoch something. Source date epoch. So one of the issue that is quite common is the build system would use the date of the source for some things like embed the dates in the files. And with this environment variable, they have, so the reproducible builds project has introduced this standard where you can pass your own epoch in there. And in Nix packages, we actually have you can set it per project, like you see here. But then the stdnf also does it for you. So this is basically, yeah, that's the stdnf setting it for you. So that's done for you. You don't have to worry about it. So that's pretty cool. Okay, les Jack. Alright, so I'm kind of done with the presentation, I think. I don't know if you want to talk about something else or someone wants to jump on the stream. Yeah, I think that's it for today. I don't have tons of things to say about this subject. So if you want to watch the slides, they're here. And then if you were interested in helping out with the reproducibility, you can join us on Nixos R13y. The R is missing in the slides. On Freenode. Yeah, it would be nice if we could enforce the checks. Ideally, in Hydra, I would also like to have a reproducibility check. I think there's one that's been added by Elko, but it's not enabled on the public instance. One of the problem is obviously it doubles the computation that's required. Roland, when is the percent of packages that are visible? I don't know. Do you have a machine with a lot of CPUs? Because basically it means rebuilding everything, and I think it takes 2 days for our Nix packages to be rebuilt from scratch. And that's with the build farm where we have, I don't know, like 50 machines. So it might take a while, you know. But my hope is we start with the minimal, so we just be focused, you know. And then we start expanding. Oh, I think there's one thing I want to talk about that we didn't really touch. So, you know, like here I'm talking about reproducibility and sorry, I kept going away from the microphone. So, you know, we're talking about security in the sense that you can have 2 different machines that check that you get the same result, and then that gives you more confidence, right? Because you can have bad actors. For example, you could have a Hydra build machine that gets hacked. Let's say, I don't know, like maybe it's a classic, but let's say the NSA really wants us to be infected, so every time rsync or some low-level tool gets built, it adds a payload to the output. So all they would have to do is hack the build farm, and then inject the outputs. So ideally you have two different systems that check that this is secure. So that's the security aspect. But there's a different part of this, which is how do you bootstrap everything? So I don't know if you know, but right now the stdinf is bootstrapped from a set of tarballs. How do you build all of Nix packages from scratch? Because you need GCC to build GCC, right? So what we have here, we have a different service that's not cache.nixos.org, but tarballs.nixos.org. And we use this to put the files that we need. So these are uploaded manually, I think. And they're generated, I don't even know if they're generated manually or if they're derivation outputs. But this is a different problem that's in the same space. And the Geeks people actually have invested in a project called GNU Mess. Mess with MES, not it's a big mess. And here what they try to do is bootstrap from, like ideally you have a napkin, you can write a program on a piece of napkin and you can verify that the program compiles to binary, like a very small binary. And then from that you would build up to a bigger interpreter, and then from that you would have a compiler, like a smaller subset of C, and then once you have this smaller subset of C, you try to build a bigger version of C until you have a C compiler, and then once you have the C compiler you can build an old version of Golang, and then you can use that to bootstrap Go, for example. But it's a lot of work. And I don't know if they have like a graph, but it's actually quite complicated. Nice. See? The Geeks people actually do also good things, right? So they talk about the problem here. So here they have a TCC. So TCC is a tiny C compiler project. And obviously to build GCC you need make and you need auto tools and bash. So it's a bit long, like this is the chain basically. But it's a good effort, I think. So that's interesting, I think. What is in22? Okay, I don't think I'm getting the right results to see here. TCC is a tiny C compiler and it's written in C, but it's written in a subset of C that's simpler. Did you ever hear about Fabrice Bellard? He's a legend. He created the FFmpeg, QEMU. So it's like, I think it's also used in teaching, like in schools when they want to teach the students how to build a C compiler. This often is used because it's a much smaller source code than GCC. And it doesn't produce super optimized binary, but in that case we don't care about that because we just want to build GCC, and then we can have the optimized compiler. And actually once you have GCC, then you rebuild GCC once with GCC. That way you have an optimized version of GCC, and then you're good. So to build tiny C compiler, I think they built another compiler that's written in Scheme, and then the Scheme interpreter is written in another language that's even simpler. I don't know the details actually. It's actually quite a mess. See, GNU-MS is the Scheme interpreter and C compiler for bootstrapping the GNU system. So the idea is to establish the correspondence. Ideally, for each step, you can prove mathematically what it does. So you could have also a mathematical proof, using Coq or something like that. Because you have the issue with compilers that, in theory, you could generate a compiler that injects sort of payload into all the binaries, including other compilers that would then propagate this payload. So here you want to verify that the first compiler doesn't have that. And for that, you need to establish the correspondence. See, here there's a M2 planet, which is another language, I think. Platform neutral transpiler. What is this? Allows to compile a subset of the C language into working binaries. I'm surprised they didn't use Forth actually, because Forth is one of the simplest language to implement. That's the manual page. I guess if we go in the source here, we can see how it looks like. That's just the test 001. Where's the M file? So it takes the C file and then it generates a M1 file. Okay. Anyway, I don't think I can figure this out. It's just like that. Not that smart. But yeah, it's an interesting project. Let's have a look at Toto. What is Toto? A framework to secure the integrity of software supply chains. Okay, that sounds good. But how does it work? Yeah, that's okay. So Nix actually does a lot of this for us, right? Like we have the fetch all the fetchers have the SHA-256, so that gives us some good guarantee in terms of, that we are fetching the same things. Then we have the signatures for the binary cache, so that gives us a good guarantee that the cache itself doesn't get compromised. Right, software updaters. Usually, that's like the signature part of in the Nix ecosystem. I don't know exactly how that works here. That sounds interesting. I guess what we're missing right now is, one thing would be to log which builder built the thing at what time, and then store that as part of the nar info in the binary cache. Oof, it's a lot to read. I don't know how many users are actually watching. We have 10 people watching me read a PDF. I'm really grateful for everyone that joins the stream. How many software engineers does it take to read a PDF? I don't know. We should shard the PDF. Everyone has a page, and then we try to regroup. So I was told to do getting started. Okay, yeah, we'd have to run this. See, it looks like they're not really in the reproducibility mindsets, actually. So there's really two schools, I think. There's I'm working with one of my customers. They're building aircrafts, and there's like the old school of the aircraft, where what they do is they produce a binary, and then they test the binary, they certify that the binary is correct, that it's working, they run a bunch of tests against it. And that's how they approach security, and they use Artifactory, and then you have like a whole list of checklists to run against the binary. and each binary is versioned. And if you have like different components in the aircraft, then each of them has its own version. And then if you have dependencies, you end up cutting a release just because you bumped a dependency or something like that. Yeah, so in Artifactory you can trace, for example, who uploaded the artifact. And then here maybe it's a bit like you actually trace who executed the build script that generates the artifact. But I don't know, I need to look into it, but it seems a bit dubious. Like at some point you need to trust the person, right? Because they could hack the Toto script and then that would produce like a record, but that would be fake. So I think like the independently verifiable approach is more powerful because you can actually, put a gap between the two verifiers. And it doesn't have to rely on making sure that the whole chain is secure. But it's interesting. I need to test it out. Yeah. Alright, so yeah, that's a short one. Like we're below 1 hour. I don't know what else I can show you. Oh, I know. Did you guys see this already? So this is going to be merged in Nix packages soon. And it's not revolutionary or anything, but I just think it's cool. And so I built this. And then I got the help from Rizari for some of the stuff. And basically what you can do is you just paste a nar star here at the end. And it's going to fetch the nar from the cache and unpack it on the fly. And then you can serve the content, right? So here we have the Go binary. There's some manual that's shipped with it, and you can just watch it. It's a bit slow because every reload is going to fetch the nar from the cache. But I don't know. It seems useful. I don't really know why or what to do with this yet. But it seems like it could be useful. I want to add some caching to the... this is running in a Google Cloud Run, so it's not too expensive to run unless you guys start hammering it. And I want to add some disk cache to the container. And you can also look at here, you can list the contents. And here it's a symlink to another store path. So you just follow, like the symlink is implemented as a HTTP redirect. And you just follow the redirect. And I had this idea that, you could have your websites be generated as a static website. And then you put the Nginx frontend that points to the store path. And there you go, you have like your static website that's as just an output. What other ideas? So here we serve the content straight from the store, but we could also have different front ends here. Imagine I can bind like the tarball. You could do something like that, and then you get a tarball out of it. Or maybe there would be a Docker one. So maybe somebody can add a Docker registry API on top of this, and then you could serve Docker images straight from the store. Oh, yeah, I'm sorry, Tim Scott. So NAR is actually the Nix archive format, and it's part of the... okay, loading the context. So yeah, it's deterministic. That was one of the design goals. It's also only for Nix, so there's no sharing with other projects. So when you go, let's say for example you have curl, okay. Actually, let me just do this. So when you install curl, what it does, it queries the cache for this, and it asks no, first it's going to query, I think there's a store info. Sorry, I forgot. There's one file that it loads that describes the cache with some metadata information. Then it looks for the nar info file. And this gives you a few information about the file. First, it tells you if you get that back, then means it's in the cache. So looking something up is very easy. You just do a request. And it gives you the nar address here. So my implementation in Go actually, loads the nar info, finds out the location of the nar, and then loads it. And then it streams the content, and it decodes the compression on the fly, and then it parses the file, and then it gives you the output. Another interesting part here is the sig. So that's the signature of the nar. So this is protected by the signature. But just this part, actually. So I don't know if it's obvious to people, like when we say that the binary cache is signed, it's actually just this part. All this metadata here could be changed by someone who has write access to the store. So yeah, then you fetch this file, and then you have like a tarball, and that contains what would be then ultimately unpacked in the /nix/store. So yeah, that's it. Does anyone have a PR they want me to review? I like to do like crazy projects sometimes. I also have this Nix experiments. So it's not orderly or anything, so I don't know if third parties can go through this. One of the things I've used recently how should I be packaging apps that are Go backends and JS frontends? That needs building with Node like React. Or any node that you wouldn't want as a node package style thing. I don't know. Well, I think I would do two packages, right? One for the backend and one for the frontend. I have some example code, but it's customer code, so I can't share it. For Node, what you can do if it's a private project, you don't care about reproducibility. You can, when you have a derivation like that, you can do run command, node modules, and here you say no chroot. That turns off the sandbox. And then you copy the package.json into the build environment. Then you copy the package log file, or I think something like that, into the build environment. Then you do a npm install. And then you copy, you have to keep the node modules as is. So the problem is with the out is it's going to contain the hash, and Node doesn't like it, so you have to create the out and then move the node modules into the out like that. And then you can use that in another build. You symlink the node modules, and you can use it for development as well. So that's a nice hack. But this is going to fail if you have sandboxing enabled. You have to set sandboxing to relaxed. Is Contrin still around? I think I was a bit abrupt when he said hi. Yeah, you're still around, Contrin. Yeah, so for node projects, one of the issues, the dependencies sets of node projects tends to be super large. Oh, you're just getting the binary here. Where is it not built from source? Oh, because you didn't figure out how to build React. Yeah, fair enough. Yeah, Node to Nix is, it's great that it exists, but it's not the most user-friendly, I think. And then it depends on the upstream. So let's take a quick look. Some projects use npm, some projects use yarn. think we had the same problem with, what was it? The HashiCorp security module. Yeah, I forgot the name. It's not Vagrants. Sorry, I have a brain fart. So where is the front end? It's here. It's using TypeScript. There's package lock, so it's using npm. I mean, technically you could build just a content address, like fixed output derivation with the node stuff. I think it would be easier if you were to come on the stream, and then we can look at it together. Yeah, there's a bunch of projects like that. To be honest, I don't really see the utility of tracking like this, like each of the package as a derivation, because this is mostly noise. Like, look at that, 25k of dependencies. That's crazy. So then what do? You add 25k to the next packages, and then it's, next packages is already super large, right? It's a symptom, I think, of the package manager. Like, if you don't have a forcing function that forces the developer to reduce the dependency graph, then you're going to end up with things like that, right? And the reason why in NPM it's the case is because each dependency can have its own version of another dependency. So it's not like other languages that at least have this, you have one version of each dependency. In NPM, each dependency can have a different version of the same dependency. So that leads to this explosion. And yeah, it's just a forcing function, right? If the people who are forced the most are the C developer, because they don't have any package manager. And so they have to be API compliant, like consistent, more than any other project, I think. Yeah, it's a good point. Nix actually doesn't force you to have the same version of everything. Well, yes and no. So if you use a build-env, like if you install 2 different versions of Ruby in your system environment, then one of them is going to win, right? So you still kind of want to solve that, because the tree is still just one tree when you create the build-env. But you still get the flexibility of having multiple versions if you need. So it's not as crazy as Node.js. And we're just a package manager of the package manager, so you could argue that it's not really our job to fix that. But yeah, it's an argument. we can argue. Yeah, there's this other question, right? Like, if you have a package that has a really deep dependency tree and their language doesn't really allow you to have different versions of the tree, then on which shoulder lies the security updates? Should Nix packages do the security updates, or should the upstream project do it? And I think the answer is for NPM and Cargo and Go to also, then this is the responsibility of upstream to fix the security updates, because they are tightly controlling the dependency tree. Whereas other languages like Python, I guess, well, C, I don't know about other languages right now, but those traditionally you would let the distribution manage the security updates. And I think in the Debian universe they have arguments around, this exact thing. But yeah, it's tricky, because let's say you do manage the versions in Nix packages, then you become responsible of the security and the functionality of the program. If you report to upstream that there is a bug, and the reason is because Nix packages is using different dependencies than what is being supported by upstream, then they might get upset and they would say, it's not our problem because we have the package lock, and so you should use this package sets. So I think as long as if they have that attitude, then they should be responsible for the security updates. But yeah, again, that's a discussion. Oh, it looks like an interesting project. I mean, yeah, I'm sort of on a fence with Kubernetes. It's either great or it's completely crazy. Yeah, Subver is useful. I can see a future where we have better tooling for each of the languages, and so we can actually help with upgrading all of GitHub, right? And actually GitHub does a bit of the same with their robots. Like the Dependabot. That's another topic actually. Like how many what is the percentage of items that you have in your feed here that is generated by bots versus humans? Historically it would be 100% humans. And here I can see there's the near bot that generates some activity. There's this one that's generated by a bot. So ultimately, I think GitHub is going to be dominated by bots writing code for us, And then we sit back and we we actually code the program that writes the code. No, I meant just Kubernetes in itself. The visualization, I think it's great. Like Kubernetes, I don't really know if it's a good thing or not. It has nice properties, but it's also an extra layer of complexity and brokenness, and I think you need to debug and maintain, and there's a release every 3 months, so you need to either have a managed cluster, and then if you upgrade in place, then you have to hope that it doesn't break. And there's this whole YAML-based API that I don't know if it's good. It's sort of declarative, but then it's not. I don't know. I've used it in the past, and it was a mixed bag. Like, there's some... It doesn't compose as nicely as Nix, in my experience. And Nix doesn't solve the same problem set, so I'm not saying that Nix is a replacement for Kubernetes. But, yeah. I don't know, there's something about Nix that really is deeply satisfying for me. You know, like, when I write my config, I know that it's going to work once it's built. And I know that there's going to be very little maintenance in the future. Even if I update Nix packages, I'm fairly confident that maybe there's a build failure, but it's fairly easy to fix. And yeah, with Kubernetes, I didn't really get that. So I don't know. I'm kind of using more of the Terraform at the moment. That's another thing I built with a friend. So I have this consulting company here, and it's basically it's me, but I employ some people, and our arrangement is I have no employee, and we're all independent, and the goal is to maximize freedom as an individual. And then you know, if you want to work for an Untitled, you can. And I'm trying to increase the number of people that come in as customers right now. And yeah, we're exploring things, we have ideas. For example, we did a few things around Terraform, like there's a shim generator for if you don't use Nix. There's another provider that's called Linuxbox that allows you to configure a VM with Terraform actually. So it treats like the VM resources as Terraform resources, right? So you can set up the swap or install Docker on a Ubuntu machine. It's an interesting approach. And then we have like a monitoring pack on top. So I can just make a quick demo. Yeah, but why do you need Terra grants? I don't really get this. Yeah, like about Nix, you know, like the composition, that's the part that's the best about Nix. You can compose package together, and it scales to a whole system, which is pretty impressive. So all of this is declared with Terraform. There's a small check here. Oops. I forgot the password. But yeah, you can have the dashboards and everything. Yeah, I don't know about what is the advantage of the Argrant. I can show you how I do it. Maybe it's gonna inspire you. The remote state bucket. I see. So that's the monorepo in the company. So here again we are playing with a few things. I don't know if it's a good idea to have monorepo or not in this context. But we have all the deploy stuff here. And then here, for example, I'm deploying the narserv using Google Cloud Run service. Sorry. And for the states, I'm using the HashiCorp backend, so I don't have to worry about the bootstrapping. Yeah, so Terraform is not super composable, like it's a bit annoying actually. Right now I don't have too much resources, so I have just one Terraform state. But if you have too many, then it becomes really long to apply. So what you would typically do is split like the infrastructure that's more like the parts that don't move, like DNS, IAM roles, things like that, into its own state. But then you have to graft the existing state into like another state, and it gets a bit messy because you have to do Terraform state move, and yeah, that's it's an operation where you need to be careful to not make any mistakes. And then artificial 01, for example. So artificial is one of my customer, and I'm providing a machine for them. And this is using the Terraform Nixos module from Twig that I wrote actually. And then you can pass the Nixos config, and when you do Terraform apply, it applies the config to the system. So that replaces Nixos. And one of the cool thing is in the narserv part, there's one design pattern that I quite like. So I realize I'm kind of out of the Nix world here, but please humor me. Where is it? Yeah. See, I kind of like this pattern where this is a Terraform module that I import. And what it does, it actually builds this, it uses the external data to build and push the Docker image. So when you access this module, it builds the image and then pushes it out. And here, because we use Nix to build the image, we have this part where it just does the Nix build, and then we use scope.io to push the image. And then we output the image name as the module output. That's kind of neat actually, because now you don't have to worry about pushing the image, it's already in sync. And everything is driven by Terraform. Same with the monitor pack. So here we have a Hessner cloud server that's running with Debian 10. So I'm just doing like a bunch of, like there's one Nixos machine, there's some Google Cloud Run, and now we have a Debian machine on Hessner Cloud. And here we configure like the swap with the Linux bugs. Bootstrap Docker. This is kind of cool as well. And then for Terraform, I just have this little wrapper that does Terraform with plugins, and it just gets the plugins. So yeah, just to go back to TerraGrunts, I'm not really sure. Yeah. So one issue with Terraform is actually when you use providers that take variables as an input, it breaks the Terraform imports, for example. So if you do configure Kubernetes with Terraform, it's good to create the cluster in one Terraform state and then configure the cluster in a second state, I think. I don't know what's your experience with that. But I agree, like kubectl is not the right way to go. Here we have the important alpacase CLI. That's this here. Very important. Then I'm using the dev shell that I'm working on at the moment. I'm using this monorepo as an inspiration because it needs to handle all the use cases. The Untitled website is actually this. So it's using Zola to build the website, and when you push, it gets deployed automatically. If I get further with rootless Nix, I'm getting closer, but there's still some issues. It's actually Rizari that's put together this website. He wanted to use Zola, so I let him. And I'm quite happy with the result. It's not complicated. There's templates, here's the contents, and then some static folder where you just dump the stuff that you want to use. So yeah, today you got to see this bit, the private repo. Here I have a service that does one thing. It returns a HTTP redirect. So it's a very complicated program. You pass the target URL and the environment variable, and then it returns the redirect here. That's just so I can redirect www.numtight.com to the naked domain. We'll will flakes and flake log files end up replacing Nif? Yes, I think so. They're starting to become fairly versatile, and the CLI is also getting better and better. I think Nif still has an edge in terms of CLI. But, it's getting there. And the main advantage is that it would ship with Nix, so you don't have to install a secondary tool. Alright, let me show you something else. So I was talking about the Nix experiments. I have a thing called root Ubuntu. And this is a way to start VM on demand. So you just run root Ubuntu. And it builds a VM, and it starts the VM on demand. Yeah, so for Home Manager, I think you have to specify the version. But let me show you this quickly. So the interest of this is everything is declared with Nix. So you have like where to fetch the Ubuntu image. Then you generate a cloud init file. And then you generate the user data. So you have to generate a disk image to put the user data, the cloud init. And then you start the VM. And all of this is done offline. And the interesting part is you can generate a snapshot of the disk and then start the VM again in another derivation. And then it would be instant because you have just a snapshot. And so down the line, my interest was to run the Nix installer, and I can test it in a fresh VM on every derivation, right? So that sounded good. That's why I built this, but it's not finished. And then I want to do the same for macOS. That would be awesome. So then we can start testing macOS builds on Linux. So next, yeah, you can build VMs. You can build disk images. If you go to Nixos generators project, here we integrate. It's just a small wrapper actually around Nix build and the Nixos module system. But basically, you can take your configuration.nix and then you pass the format that you want to have as an output, and you get a VM image. And it supports Amazon images, Azure, CloudStack, etc., etc. So with the same configuration.nix that you have on your machine, for example, you can target all these different targets, which is cool, right? Like one of our customer is shipping, they built their own software and then they want to ship it to enterprise. And the problem they have is some customers are running on VMware, some people are using QEMU or some other technology. And with Nix, because it's super composable, you can just generate a different image and that's it. You can as well generate an ISO image, installer image, whatever. And you have the VM here, target. And what it gives you is a QEMU wrapper script that bind mounts your Nixstar into the VM, so the actual output is fairly small. And that's just for testing, but it allows you to run your system config. And if you go Nixos rebuild, you can do the same. Here you have build VM. So instead of doing a Nixos rebuild switch, you do Nixos build VM. And then you run that and you can test your system config in a VM. I wanted to figure out the next issue that Kelly Jack was mentioning. Obviously, searching for Nix is not really good. Actually, I don't know why. I'm not sure it installs Nix. At least on Nixos, I'm using Home Manager and I'm still having the system Nix here. So it might be something else, Kelly Jack. Rizari is working on revamping to do MVC Nix at the moment. I think he wants to add different backends like PureScript and no, that's the front end, but like Rust backend, Go backend, etc. Because here we had only Haskell. And to do MVC Nix is a project that's the goal is to show people how to do Nix packaging or like how to set up your project. No, I'm just running it as alongside Nixos, the Home Manager. So I have this repo here. And I'm using dirnv to load the environment variables. And that sets the Home Manager config. Then I just do Home Manager switch. And then the system are built with using Flakes. But I didn't update Home Manager to Flakes yet. I don't know if it supports it yet. So here I have a bunch of machines. So that's my internal network. That's the machine I'm talking to you from. Then I have a laptop, and this is a server that I run with a bunch of services. So here I have more experiments, like I don't know, I was trying Home Assistant. Today I was trying Narsurf on my LAN, Prometheus, etc. So each machine has their little switch scripts like this. That's does a Nixos rebuild and then deploys to the machine. So that's how because it's a fixed set of machine, I can deploy it to my laptop from my desktop and reversely. And then when I push this, it gets built by the CI and populates the binary cache. I have my own binary cache. And that way I don't spend too much time rebuilding. Especially on the laptop, that's a good thing. Yeah, thanks. Thanks, Tim Scott and Kelly Jack. I'm actually going to stop the stream as well. Thanks for watching and see you next week. I don't have anything planned, but we're gonna go freestyle as usual. Yeah, and if you want to join the stream, you know, we could have a conversation that's less one-sided. I would be happy to have a chat with faces and things like that. All right, have a great weekend and enjoy your week. See you next Friday.